elements of first transition series are used in making alloys. So we have give reason for this point. The reason for that because their atomic radius is nearly constant. My dear student, notice that the ionization energy increases from left to right across the periodic table with the increasing of atomic number, and the oxidation becomes more difficult. Now we are going to discuss the next property, which is the metallic property. Here the elements of the first transition series are solid metals having a metallic luster and good conductor of heat and electricity. Also, these elements have high melting and boiling point, and so we have give reason for this point. The reason for that is due to the strong interatomic bonding, which is metallic bond, that involves the electrons of 4s and 3d sublevels in their electron cloud. My dear students, the transition elements, they have high density, which increases with the increasing of atomic number, and so we have give reason in this point. The reason for that, my dear student, because their atomic mass increases with increasing of atomic number while their atomic radius is nearly constant. So the density equal high mass over constant volume give higher values. My dear students, the first transition series have variable chemical reactivity, and so we have give reason in this point. The reason for that because the copper has low reactivity while iron has medium reactivity as it rusts when exposed to air, and scandium has high reactivity. The next property, my dear student, which is the magnetic property. The first transition series elements are attracted to an external magnetic field, and we have give reason for this point. The reason for that is due to the presence of unpaired electrons in the 3d orbitals, such that the magnetic field is resulted from their spin motion is attracted with the external magnetic field. My dear student, we have to define what do we call the magnetic moment. The magnetic moment, it is the number of unpaired electrons in the d sublevel. So the magnetic moment increases till we reach manganese, as it will be half-filled d sublevel d5, so having 5 unpaired electrons. Then it decreases again and it till reaches 0 at zinc. My dear student, the magnetic moment determines the electronic configuration of their ions, and so we have give reason for this point. The reason for that is the measurement of their magnetic moment indicates the number of unpaired electrons in their 3d sublevel. Now, my dear students, we are going to discuss the types of magnetic properties. The first property is paramagnetic property. This property appears in ions or atoms or molecules in which their orbitals having unpaired electrons. Their magnetic moment depends on the number of unpaired electrons, which lead to the attraction to an external magnetic field. The paramagnetic substance can be defined as the substance that attracted to an external magnetic field due to the presence of unpaired electrons. The second property, which is diamagnetic property. This property appears in the substance which the electrons in all orbitals are in paired state. Their magnetic moment is zero, as they repelled out in an external magnetic field, as the paired electrons spin in opposite direction. Now we can define the diamagnetic substance. It is the substance that repelled out in an external magnetic field, as the electrons in all orbitals are in paired state. My dear student, notice that most of compounds of transition elements are paramagnetic. So we have good reason in this point. Zinc chloride is diamagnetic, but manganese chloride is paramagnetic. The reason for that zinc positive 2 ion in the compound has electronic configuration argon 18 3d10, as losing the 2 electrons from 4s sublevel. So all the electrons are paired in the completely filled d sublevel. While in manganese positive 2 that has electronic configuration by losing the 2 electrons in the 4s sublevel, it will be argon 18 3d5, so having 5 electrons are unpaired in the d sublevel. That's why it is paramagnetic substance. Another good reason in this point, iron 3 compounds have higher magnetic properties than iron 2 compounds. The reason for that, iron positive 2 that has electronic configuration argon 18 3d6 as losing 2 electrons from the 4s sublevel, so having 4 unpaired electrons in the d sublevel, and so have lower magnetic moment than iron positive 3 that its electronic configuration argon 18 3d5. Now, my dear student, we are going to discuss some examples on magnetic property. Which of the following substance is paramagnetic and which is diamagnetic? Zinc that has 10 electrons in the d sublevel, copper 2 ion that has 9 electrons in the d sublevel, and iron 2 chloride in which the iron has the electrons 6 in the d sublevel. Write the order of their magnetic moment. The answer, as shown in the following table, the electronic configuration of the d sublevel and the number of unpaired electrons that decide the magnetic moment, and then the type of magnetic property. In zinc that has d10 electrons, there are no unpaired electrons here. The number of unpaired electrons equals 0. So the magnetic moment here is 0. So it has magnetic property will be diamagnetic. Here copper positive 2 ion that has d sublevel containing 9 electrons. The number of unpaired electrons is 1. So the magnetic moment equal 1. And so the magnetic property here will be paramagnetic as containing 1 single electron. Iron positive 2 that has 6 electrons in the d sublevel, that the number of unpaired electrons here is 4 and the magnetic moment equal 4. So the magnetic property of that element, it will be paramagnetic as having 4 single electrons. Next example, study the magnetic property of the following transition salts: iron 3 sulfate and titanium 4 chloride. The answer, in the iron 3 sulfate, the iron here has positive 3 oxidation state. That means the electronic configuration will be argon 18, 4s0 and 3d5. So it is paramagnetic as having magnetic moment 5 ampered electrons. While in titanium chloride, titanium 4 chloride, the titanium here has oxidation state positive 4. That means the electronic configuration, it will be argon 18, 4s0 and 3d0. That means it is diamagnetic and has 0 magnetic moment. Next example, study the magnetic properties of the cations of the following transition salts. Then arrange them in the ascending order according to their magnetic moment. Iron 3 chloride, copper 1 chloride, chromium oxide, and titanium 4 oxide. The answer here, in iron 3 chloride, the iron ion has oxidation state positive 3. That means it contains 5 electrons unpaired in the d sublevel. So it is paramagnetic and has magnetic moment equal 5. In copper 1 chloride, here the copper positive 1 ion has electronic configuration argon 18, 4s0, 3d10. So the diamagnetic substance here and the magnetic moment equal 0 as it has no unpaired electrons. While in chromium oxide, the chromium ion, the chromium positive 3, the oxidation state is positive 3 of electronic configuration argon 18, 4s0 and 3d3. So has 3 unpaired electrons, so it will be paramagnetic and the magnetic moment equal 3. And in titanium 4 oxide, the titanium ion positive 4 has 0 electrons in the d sublevel, as the electronic configuration is 4s0, 3d0 for titanium positive 4. So has no unpaired electrons. So it is diamagnetic and the magnetic moment equal 0. So their arrangement in ascending order, titanium 4 oxide, copper 1 chloride, chromium oxide, and iron 3 chloride. The role of the catalyst in the chemical reaction, the electrons in 4s and 3d orbitals form weak bonds with the reactant molecules. Then the concentration of reactant increases at the surface of the catalyst. So the weakness of the bond in reactant molecules. That leads to decreasing the activation energy, which means decreasing the amount of energy needed to break the bond in the reactant molecules. That's why the rate of reaction will be increased. My dear students, we are going to show the effect of catalyst manganese dioxide in the decomposition of hydrogen peroxide. As shown in the graph here, across the energy and the progress of reaction and the two axes, we find that the reactants need a lot amount of energy for breaking the bonds between the molecule of the reactants without the catalyst. But when using the catalyst, the activation energy is decreased and the amount of energy needed to break the bond will be decreased. That's why the activation energy with catalyst will lower the energy needed to the reaction to be occurred. So, my dear students, here some examples of catalysts in chemical reactions. The divided nickel in hydrogenation of oil, divided iron in ammonia formation, as in Haber-Bosch process, as nitrogen gas and the hydrogen gas react in the presence of catalyst iron or molybdenum at 500 degrees Celsius and 600 atmospheric pressure to giving ammonia gas. And the next example is vanadium pentoxide in sulfuric acid industry. In contact method, sulfur dioxide gas is oxidized in the presence of vanadium pentoxide at 450 degrees Celsius, giving sulfur trioxide gas. Then, sulfur trioxide gas dissolves in water, forming sulfuric acid. Now, my dear students, we are going to discuss the colored ions, which is the last property for the first transition series. Here, most of the compounds of the transition elements and their solutions that we call hydrated ions are colored. The explanation of the color. When white light, which are 7 colors of the spectrum, fall a transition element, we find that the unpaired electrons in the 3D sublevel absorb some photon invisible light. That means these are raised the electrons in higher levels while the other colors are reflected, giving the eye the apparent color of the element. My dear student, notice that the absorbed color is known as supplementary color, while the apparent color, which is the reflected color, is known as complementary color. Here, my dear student, we find that the ion and the outer configuration of the element ion and the number of unpaired electrons and the color of the ions. Here, we are going to discuss some examples. You are not to keep it, my dear student, just for illustration. That scandium, positive 3, has electronic configuration in the outer d sublevel 3d0, so no unpaired electrons here, so it is colorless. While titanium, positive 3, has 1 electron in the 3d sublevel, so has 1 unpaired electron, so has color, which is red-violet. And vanadium, positive 3, has outer electronic configuration 3d2, so 2 unpaired electrons, that has color is blue. And chromium, positive 3, has 3d3, and the number of unpaired electrons here is 3, and its color is green. And manganese, positive 3, has 3d4 outer configuration, so 4 unpaired electrons, has violet color. And manganese, positive 2, has 3d5 electrons, and so 5 unpaired electrons, which is pink. So the color of the compound depends on what? Depends on the absorbed color and the complementary color. My dear student, the absorbed color is called supplementary color, and the reflected color, which is complementary color. Actually, the absorbed color is one of the colors of the visible spectrum, while the other colors that are reflected appears to us by one color is called complementary color. So when the absorbed color is violet, so the complementary color is yellow. And blue, when it's absorbed, the complementary color is orange. And green, the complementary color is red. When the absorbed color is yellow, so the apparent color to eye, which is the complementary color, is violet. And when the absorbed color of the visible spectrum is red-purple, the complementary color that appears to eye, it will be green. So we have give reason in this point. Chromium 3 compounds appear green. The reason for that, because they absorb red light to raise the 3D electrons to a higher level, while the other colors are not absorbed, so appear green. My dear student, notice that the absorbed color, which is a supplementary color, plus the reflected color, which is a complementary color, gives the white light. So, my dear student, the colorless compound occurs if the sublevel is completely filled by electrons, as zinc positive 2 and copper positive 2. also occurs when the d sublevel is empty, as scandium positive 3. So we have give reason in this point. Copper positive 1 ion is colorless, but copper positive 2 ion is color. If you think about it, my dear student, you have to write the electronic configuration of copper, then you write the electronic configuration of copper positive 1 and the electronic configuration of copper positive 2. So the reason for that, copper positive 2, argon 18, 3d10, so no unpaired electrons in the d sublevel. So all electrons are paired in completely filled d sublevel. But in copper positive 1, the electronic configuration argon 18, 3d9, so having one unpaired electron in the d sublevel. Now, my dear students, we are going to discuss some questions here. So, my dear students, we are going to discuss first. Choose the correct answer. In the same period of transition element, as the atomic number is increased, its ionization energy decreases, its diameter increases, it is difficult to be oxidized, its density decreases. If you think about it, my dear student, you will find the answer. It will be, it is difficult to be oxidized. Next point. Zinc 2 ion is characterized by its diamagnetic property due to what? Presence of 3d paired electrons, or 3d sublevel is filled by 8 electrons, or 3d sublevel is empty, or the presence of unpaired electrons in 4s sublevel. If you think about it, my dear student, you will find the answer, the presence of 3d paired electrons. Next point. Iron 2 ion is characterized by its paramagnetic property due to what? The presence of 3d unpaired electrons, or 3d sublevel is filled by 10 electrons, or 3d sublevel is empty, or the presence of unpaired electrons in 4s sublevel. Yes, if you think about it, my dear student, it will be the presence of 3d unpaired electron. Next point. The copper 2 ion is characterized by its paramagnetic property due to what? Is the presence of 3d unpaired electrons, or 3d sublevel is filled by 10 electrons, or 3d sublevel is empty, or the presence of unpaired electrons in 4s sublevel. If you think about it, my dear student, yes, it will be the presence of 3d unpaired electrons. The second type of question is write the scientific term. Elements that have partially filled d or f sublevel in their free state or ionic state. If you think about it, yes, it will be transition elements. Next one, elements in which d sublevel is successfully filled. Yes, the answer, my dear student, it will be main transition element. Next one, the elements in which f sublevel is successfully filled. If you think about it, yes, the answer, it will be inner transition element. Substances which are repelled out with the external magnetic field because all their electrons are paired. If you think about it, my dear student, yes, it will be diamagnetic substance. A substance that is attracted to an external magnetic field due to the presence of unpaired electron. If you think about it, yes, it will be paramagnetic substance. My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed today. So till we meet again, my best wishes for you.